Okay, so the last section we're going to look at this week is 1.3. We're going to start it today, but we won't finish it until next time we have class, next academic week. Tomorrow we have our test on what we've covered this week, so that'll be 1.1, 1.2, and 1.3 part 1. At the end of the video, I'll put a list of topics that are going to be on the test. Okay? And I should have enough time to get that up before you guys leave. If I don't have enough time, what I'll do is pause the video. When you guys are at lunch, I'll put the topics on, and then it'll be there after. Okay, so in the rent-a-car problem, we had this equation, y equals 0.2x plus 15. And the x and the y were the two variables. X was the miles, and y was the cost. Now, I gave you a name for those two variables. Does anybody remember what I called the x variable? Began with an I. Yeah? Independent. That was called the independent variable. And what about the name I gave to the y? Anybody remember that one? Yeah?
The dependent.
The dependent, yeah. And there's a few different names for the x and the y. Independent and dependent are one pair of names. You can also call them input and output. Think of the x as something you're plugging a number in for. When you plug the number in and do the arithmetic, you'll get an answer out of the formula. The answer that you get is called the output. Two other names we'll use quite a bit are domain and range. Okay, but they all mean kind of the same thing. So think about the x variable for a minute. It was the number of miles you drive the car. If I asked you what kind of numbers would make sense for x, what would you say? What kind of numbers could you fill in for the x variable? Yeah?
Real numbers?
So like negative 12 would be okay?
Like positive. 0, not.
Yeah, any real number that's not negative, which would mean any real number is 0 or positive. 0 or higher. Okay. So plugging in any number 0 or higher for x, we would call that the domain of the function. It's the numbers you are allowed to plug in based on the word problem. And the range is the type of answers you would get out. So in our case, range was the cost to rent the car. What kind of numbers made sense in this problem for the total cost you would pay to rent the car? And let's say you called the company, and let's have this assumption. You called the company, you booked the car. Okay, so it's booked. So think about, even if you don't drive it, you booked it. So what kind of numbers would make sense for the costs that you could pay? Yeah?
Numbers greater than 15?
Yeah, greater than or equal to 15. Okay, even if you drive 0 miles, you already booked the car. It's like a non-refundable deposit. So your range in this case would be all numbers 15, or numbers 15 and up. Might not be every number. Actually, yeah, it could be. It depends on how they round the mileage, right? If they round to the nearest mile when you drive the car, then you might only pay certain amounts. But if they actually plug in the real mileage, like right to the 10th or 100th of a decimal, then the range could have lots of numbers in it. That's the idea. All right, so not every equation that you write down, or not every graph that you draw is a function. Okay? For an equation to be a function, it has to have something special about it. And this is what it has to have. Basically, for an equation to be a function, that means when you plug in a number for x, you will always get one answer for y. exactly one answer. If you get more than one answer, that's not a function. Here's an example of a function. Y equals 3x plus 4. If I plug 2 in for x, what will I get for y?
Do it 10.
10. Will I ever get anything other than 10?
No, I'll keep it 2.
No. If you plug in 2, you will always get exactly one answer, and that answer in this case is 10. You'll never get anything different. So that's a function. Let me show you something that's not a function. Let's look at this one. If I plug in, let's write it as like a coordinate. If I plug in 8 for x, what's 2 times 8?
16.
16. And what's the positive square root of 16? 4. So if I plug in 8, I'll get 4. Now, if I plug in 8 again, 2 times 8 is 16. What's the negative square root of 16? Yeah. Does negative 4 times negative 4 give you 16? Yeah, and that's also an answer. So when you do that one, there are 2 answers when you plug in the number 8. You get 4 and you get negative 4. That is not a function. There are 2 different outputs for the number 8. Any question why that one is not a function? All right. So that's the idea. You plug in a number, you get exactly one answer. I kind of already said this to you earlier. Domain and range. Domain are all the numbers you are allowed to plug into a formula. Range are all the answers that you get out. Now, when you're dealing with a word problem, you have to use a little bit of common sense, because there are sometimes numbers that wouldn't make sense. Right? When we had the formula for the cost to rent the car, algebraically, you could plug in any number for x. You could plug in negative 76.5 if you wanted, and you will get an answer. The problem is it doesn't make sense in the word problem. Okay, so sometimes there's certain values you cannot use in the domain because they just don't make sense in the word problem. It's not possible to like spend negative $10. You don't buy negative 8 concert tickets. So sometimes things like that don't make sense. Even positive numbers, like when you're buying, let's say you go to the store and you want to buy like gallons of milk. Right? You can't buy 2.64 gallons. It's not like they just have a big dispenser and you just fill it up with however much you want. You either buy 1 gallon or you can buy 2 gallons. Or maybe if there's a smaller container, you get that. But you can't buy any amount you want. Right? There's certain container sizes. You have to buy those sizes because that's what they sell. Unless otherwise stated, we are working in real numbers. Okay? So what I'm saying here is we don't want to think about imaginary numbers. Okay, we're not going there with the domain right now. Now there's 2 things that we have to be careful when we're talking about domain that don't have to do with a word problem. Just the equation itself. If I wrote something like this, we have to be very careful what we plug in for x there. Not because this has anything to do with a word problem. It doesn't. Because it has something to do with a rule you need to follow in math. Right? When you have a fraction, there is a number that you are not allowed to divide by. What are you not allowed to divide by? What number?
0.
You cannot divide by 0. So if you could plug something in right here, and it could make the bottom 0 somehow, that's an issue. We would have to say that that number is not in the domain. So is there any number that you could plug in for x, and it would cause the bottom to come out to 0? Yeah?
5.
5, yeah. So in this particular problem, the domain is any number you want, all real numbers, except you cannot plug in a 5. Okay, no 5. Any question why you can't use a 5 there? And it's not always a 5, you know, it depends on what's in the bottom. But in this case, it's a 5. So fractions with letters in the bottom is one thing we have to be very careful about when we do domain. The other thing we have to be careful about is something like this. Let's say we had the square root of x plus 2. There are certain numbers we don't want to try to take the square root of. Not because it's a word problem, but because it's a rule in math. What kind of numbers don't we want to try to take the square root of? Because if we do, it would be imaginary. Yeah?
Negative number?
Yeah, we don't ever want to try to take the square root of a negative number. You can take the square root of 0. I think people mix that up with dividing by 0. You can't divide by 0, but you can take the square root of 0. That's fine. 0 times 0 is 0. So this, we always have to make sure that whatever is under the radical symbol is 0 or higher. Okay? So x plus 2 always has to come out equal to 0 or higher than 0. What does that mean you would be allowed to plug in for x then? What numbers could you fill in for x and make sure that what I have circled in green is always 0 or higher? Yeah?
-2 or more.
-2 or more. Yep. If you solve this equation, you would end up with x is greater than or equal to -2. That's what we would say the domain is in this problem. You cannot plug in a number like -10. It won't work. It has to be -2 or higher. So we'll talk a lot more about that, but those are the two big things you really need to be careful about with domain. Are you dividing by 0? Are you taking the square root of a negative? We need to avoid those two things. Any questions on why we need to avoid those two things? Okay. So this actually kind of came up in the homework, and somebody asked me about this. When you're writing a function, this is one notation, y equals notation. But there was another notation that I used instead of the y. Does anybody remember what I wrote down instead of the y? Yeah?
F of x.
Yeah, f of x. F of x means the same thing as y. It's just a different way of writing it. The reason why you might see this notation is because if I had this on the board, and I wanted to distinguish between those two equations. Well, they both say y equals. So I mean, I could say, look at the one with a slope of 3, or look at the one with a slope of 8. I mean, I could say something like that. Or I could just name the top one f, and I could name the bottom one g. What putting a letter here does, it's a notation that allows you to give a name to the formula you're talking about. Now I can say, look at function f, or look at function g, because they have different names. So that's really the main advantage of that notation. The calculator will always use y equals notation. That's how it does it. Okay. Any questions on that? Yes?
Not related, but will I miss much if I head off to the bathroom?
No, a little bit, but it'll be on the video. Yeah.
Alright.
Yeah. Just make sure you sign in the morning. All right, so let's try one. And we gotta be careful. This is one of the types of things you said you gotta watch out for. It says, find a complete graph. Okay, so first of all, what does this mean you need to write down on your paper? There's a little confusion about that in the homework. Find a complete graph. You gotta write something down. You do it on the calculator, but you gotta tell me something. Yeah?
Would it be an inequality?
So you could write your answer as an inequality, but what are you using the inequality to describe? You need to tell me the
window.
You gotta tell me the window. If you want to write the window as an inequality, you can. If you want to write it as an interval, you can. But you gotta write something. Okay, so find a complete graph, and then find the domain and the range. All right, well, before we graph it, let's start with the domain. What did I say about taking square roots? You want to make sure that what's under the radical symbol comes out to what number or higher? Yep.
0.
Right. It's got to be 0 or higher. I'm not saying you can plug in a 0 for x. I'm saying the whole thing that I circled has to be 0 or higher. So to make what's under the radical 0 or higher, what kind of numbers can you pick for x? That's going to be my domain. Yeah.
2, 3 or higher.
You can pick numbers that are 3 or higher. 3 or higher. So one way you can write your domain is x is greater than or equal to 3. Or let me show you how to do it as an interval. If you can pick numbers 3 or higher, what's the lowest number you'd be allowed to pick? 3. Comma, what's the highest number you'd be allowed to pick? Think about it. If you can pick any number 3 or higher, what's the highest number? All right, so there is no highest number. What's the concept that would represent the highest possible value? Infinity. That's the highest value. Now look at the number 3. Are we allowed to include the 3, or is it just bigger than 3? We include it, so what kind of symbol do we put? Bracket. Now, infinity. Can you include infinity? Like, can you say, okay, I reached it, I'm at it? No, you never can reach it. So infinity always gets a parenthesis, because even when you think you're at it, you can just go a little more, and now you're past it. So you can't reach it. But you can reach the number 3. Okay? So that's your domain. Both answers are the same. One's an inequality, one's an interval. Right. Let's do the range. Range is usually helpful to graph it, but in order to graph it, we need to set the window, and that's part of what the domain tells me. So that's why I do the domain first. So square root of x minus 3. So I'm going to go to y equals. Did we talk about where square root is yesterday? Yeah. So square root x minus 3. Now I know my domain is 3 and up. I might set my window 2 and up, just so I have a little bit of extra space. Okay, so let's go 2, and since it's the square root of x minus 3, I mean, we could let x go up to, let's let x go up to 100. Because when you take the square root of a number, it gets pretty small. So you can let the x get pretty big. If you plugged in 100 right there, what would you end up with under the square root? 97. And the square root of 97 is pretty close to what number?
10.
Yeah, it's pretty close to 10. The square root of 100 is 10. The square root of 97 is probably like 9.8, 9.9, something like that. So I would say for my y max, we can just leave that at 10. Y min, I would just, let's try the standard negative 10 to 10. All right, let's hit graph. Perfect. There's my square root function. It's a parabola on its side. That's what a square root looks like. Specifically, half a parabola. All right, so the domain is every number from 3, and it's just going to keep going to the right. Now, if I zoom in over here a little bit, you can probably see it a little better. What I want now is the range. Okay, I want the range. I'm going to be careful because what happens is when you try to draw things on the calculator that start to get really steep, sometimes the calculator can't do it. Right? And that's what's happening here. It's getting very steep. This blue line should actually go down a little bit lower. And it's not showing it the way it really should. Let me show you how I know that. Let me put a line in at 0.2. Let me go a little higher. Let me go to 0.3. And just kind of show you something. Okay. Does everybody agree that the way the screen looks right now, that blue curve does not go below the red line? Okay, so you might think, oh, it doesn't go below it. Let me zoom in a little bit and watch what happens. Okay, looks like it's above the red line. I'm going to zoom in. What do you think now? Does it go below the red line now? Yeah. It actually goes all the way down to the axis. Okay. And the way I can tell that it goes down to the axis is if you plug in 3, which is a number you're allowed to plug in. What's 3 minus 3? 0. And what's the square root of 0? 0. So the point 3 comma 0 is on this graph. That point is on it. And then it should curve up like that. That's how the graph should look. So you got to be careful with the calculator sometimes. Okay, so the range, those are the y values. Look at the line, look at the curve in blue. What's the lowest that that blue curve ever goes on the y-axis? It goes down to 0, that's the lowest. And how high up is that curve going to go? Infinity. It just keeps going. Yep. So we can write the range as 0, and we do hit 0 up to infinity. Or, if you want to write it as an inequality, it's any number 0, including and up. Okay. And they did say to write down the window. Since I did some zooming in and out, I let the calculator pick some values. That's why the values look so weird, because the calculator picked decimals. I think what we had originally was fine. We had like, I think we had 2 for the x-min. We had 100. And then we had negative 10 and 10, I think.
Yes.
Those numbers are fine. Okay, so those are what you'd have to write down for your window. Okay. So any questions on finding the domain and the range in that graph? Let's look at this one. First thing I ask myself is, does this graph have one of the 2 things I said to be careful about? Does this graph have a square root in it?
No.
No, it's got a square. That's different. That's not a square root. Okay, so there's no square root. Does it have a fraction where there's some kind of letter in the bottom? No. So the 2 things that could give you a problem in the domain are not in this problem. So the 2 issues that could come up do not come up in this problem. What do you think that means your domain would be then? The two things we need to watch out for are not part of this problem. Yeah?
Infinity?
Okay, that would be the highest number you could pick. What would be the lowest number? Yeah?
Negative.
Negative infinity. Yep. The domain in this problem is any number you want. You can take any number and raise it to the second power. Anything. Positives, negatives, zeros, fractions. Yep. All right, so let's graph that. So let's type in x squared minus 4. And I'm going to do zoom 6 because I want to reset my window back the way it was. So domain is left and right. We know this parabola is going to go left and right forever. It's just going to keep getting wider and wider and wider the more you zoom out. But how about up and down? Does that parabola go up and down forever?
No.
No. Okay. Does it go up forever?
Yes.
Okay. So then we could at least say the highest value, if it goes up forever, is infinity. If you're saying it doesn't go down forever, then you're saying it stops somewhere. Where does it look like the lowest number is that this parabola goes?
-4.
Negative 4. Yep. And will it hit negative 4? Yes, it will. If you plug in 0 for x, 0 squared is 0, and 0 minus 4 is negative 4. So 0 comma negative 4 is a point on this graph, and it hits it right there. Because I hit negative 4, would I put a bracket or a parenthesis on it? Put a bracket. Yep. So that's your domain, and that's your range. Okay. Any question on that one? What's the difference between the problem I'm doing here and the one that I did up above? Yeah?
It's the absolute value.
Yeah. And what does absolute value do to something? It makes sure that it's always what?
Positive.
It's always positive. So if part of your graph dips down below the x-axis, what the absolute value is going to do is it's going to take that part and flip it up. Okay. So let's graph it. But you're going to see when the parabola tries to go negative, it's not going to be able to. It's going to have to stay above the x-axis. So we can type in, I don't think I showed you absolute value yet. It's under math. And then you're going to press the right arrow and go to number. The first thing you see under when you press math and number is ABS. Press enter, and you should get your absolute value symbols. There's no button you can directly press to get those symbols. I don't think it's listed anywhere.
How'd you get that?
Math, and then press the right arrow and go to number. And the first option will say ABS, which is absolute value.
Right.
Yep. Okay, so it's going to look just like the graph we had before, except look what happens when it tries to dip down below. It's like it flips it up. So one of these is going to stay the same. Which one is still the same? Yeah.
Would be range.
So range before it went down to -4.
Oh, no, I'm sorry.
It's not going that low anymore.
The domain.
The domain. Yeah, we didn't change the domain. There's no square roots here, and there's no variables in the bottom of a fraction. So you can still plug in any number you want. But the range is no longer from -4 and up. What does it look like the range is now?
2 and negative 2.
The range is between 2 and -2?
It looks like.
So if the range was between 2 and -2, that would mean the graph never goes higher than 2, and it never goes lower than negative 2. That means the whole graph would be trapped between those black lines. But does the graph go outside those black lines? Yeah. So the range is not between negative 2 and 2. Anyone have another guess? Yep.
0 and infinity.
Yeah. It's between 0 and infinity. It never goes below 0, but it goes up forever. Yep. So the range is 0 to infinity. And it does hit 0. It actually hits it twice where the points are in the graph. Hits it in 2 spots. All right, so it takes a little practice. Range is the harder one to do. Usually we'll draw a picture on the calculator to figure out range. Domain is easier. You just have to make sure you're never dividing by 0 and you're not taking the square root of a negative. Okay, so evaluate. What does that mean? So when you see something that says evaluate, they're going to give you something to plug in. Sometimes it's a number, sometimes it's a letter. But whatever they give you, you plug it in, and then you simplify as much as you can. So what they will generally do when they ask you to evaluate is they're going to give you a number for x. And they might say something like, find f of 5. That means to take 5 and fill it in everywhere you have a letter, and then tell me what the answer is. Now, in order to do that, I need to give you a formula. Okay, so the formula we're going to work with is x squared plus 1. And I'm going to have you plug in different things for x and tell me what you got. Okay, does everyone have the top part?
Where?
Okay, so this is called evaluating a function. You know what? I can probably do it right here. Okay, so the first one they want me to plug in, you can do it below. I'm just trying to keep everything on the board at the same time. They want me to plug in negative 2 for x. Whenever you plug something in, it's a good idea to put it in parentheses. Did we talk yesterday about what happens on the calculator if you don't put parentheses around a negative number when you raise it to a pound? No.
An error?
Well, you won't get an error, but you won't get the right answer. What is negative 2 to the second power plus 1?
5.
Yeah, it should come out to 5. Okay, watch what happens if I do negative 2 squared plus 1. That gives me negative 3. So what's happening there is when you do negative 2 squared, it's following order of operations. The first thing it does is square the 2, because the exponent is only on the 2 when you write it that way. You get 4. Then it throws a negative in front of that. So it says it's negative 4. If you want to square the negative 2, the negative with the 2, you need it in parentheses, like that. Okay? So the correct answer here is 5. Okay. How about if you plug in 3 for x? What would you get? Yep, you would get 10. 3 to the second power is 9, plus 1 is 10. How about if you plugged in a in place of x? Now we're plugging in a letter. Yeah?
It'll just be a squared plus 1.
It'd just be a squared plus 1. And I got one more we'll do. Let's plug in x minus 3. So everywhere you see a variable, plug in what I'm telling you right there. So it's x minus 3 squared plus 1. How do you square x minus 3? Sometimes there's a word people use to remember like how to do it.
So can you repeat that?
So how do you square x minus 3? How do we do that out?
We rewrite it twice.
Okay, yeah, you could, if you want, you could write it twice. So x minus 3, x minus 3. Okay, now how would you do all that out? Yeah.
You.
Yeah, anyone remember? Yeah.
You would multiply the x by the x in the other one.
Okay.
And also the x by the 3.
Okay, and what's x times x?
X over 2, x with 2 exponents, sorry.
Yeah, x with an exponent of 2, x squared. And then you said to multiply the x by what?
The negative 3.
The negative 3. And what's x times negative 3?
Negative 3x.
Okay.
And then take the 3x in the first parentheses and times that by the x.
So then x times negative 3, which is how much?
Negative 3x.
Negative 3x again.
And negative 3 times the negative 3.
And negative 3 times negative 3, which is
9.
9. And then let's do plus 1 at the same time.
10.
10. All right. And what's the last thing I could do with that to write my final answer? Yeah.
X squared, no, sorry. Yeah, x squared minus 6x plus 10.
Yep. X squared minus 6x plus 10. Perfect. Right, so that's called evaluating. Just plugging in something into a formula and giving me the answer. All right, any questions on that? Okay, so last thing. So I told you that not everything is a function. What did I say, like the first thing you wrote down? What did I say the definition of a function was? For every value that you plug in,
It'll give you one answer.
it gives you exactly one answer. Another way to think about that is more of a visual. I gave you, I think my example had plus or minus square root 2x, but anytime you put a plus or minus in front of a square root like that, it's not a function. Let me draw that and you can see what it looks like. So if I plug in square root of x, second square root of x, and the only way I can do plus or minus, I have to do two separate ones. So I'll do the plus, now I'll do the minus. And just pretend like it's all the same color, like that's one picture. Let's look at that graph for a second. If you plug in 4 for x, okay, let's just move this line over here. 1, 2, 3, 4. If you plug in 4 for x, how many different times does that line hit my graph? Hits it twice, right? If you plug in 4 for x, one answer, the square root of 4 is 2. And the other answer for the square root of 4, negative 2. It's two different answers. Does anybody know the name of this test that I drew on the board? It's the test to see if something is a function when you have a picture. And it has to do with this. What is that thing in black right there? Looking at that thing I drew in black, what would you call that black thing? Yeah?
Vertical line?
It's a vertical line, yes. So there is something called the vertical line test to see if something is a function. If you draw a picture and it is a function, it will not hit twice. If you draw a vertical line and it does hit twice or more, it's not a function. Okay, and that's called the vertical line test. So if you can put a vertical line in your picture and it hits more than once, that is not a function. Hitting more than once means you are getting two different output values, and you can't get two, you can only get one. Again, vertical line test. Any questions on that? All right, so that covers everything that is going to be on our first test, from 1.1 up to the first part of 1.3. So the homework, we already did the homework from 1.2. So I'm going to erase page 20 because we did that one. And the homework tonight is just the page 30. So 3 through 8 all. 11, 13, 16 to 19 all, and 24. Okay, so I'm going to pause the video, and then I will put the list of test topics up. You've got about a little over 20 minutes left. So you've got time, you could start that, and then when I put the list of test topics up, if you have any questions on them, you can ask me.